Every day, someone turns on a tap and washes their hands. A nurse cleans a wound. A surgeon prepares sterile tools. A hospital room is wiped down before the next patient enters. These actions feel so ordinary now that they can almost disappear into the background of modern life. We do them because we believe there is something worth stopping, even when we cannot see it. But medicine did not always know what it was trying to stop. For a long time, illness was understood through what people could observe directly. The fever on the skin, the smell of a room, the condition of a wound, the air around a patient, the decay of matter, the weakness of the body, or the balance of internal forces. Those explanations were not foolish. They came from the world people could see, smell, touch, and experience. Germ theory changed the direction of medicine because it asked a different question. What if the real danger was not only in the visible suffering after disease appeared? What if many infectious diseases began with something too small to see, something that could enter the body, spread, multiply, and be interrupted before the worst damage appeared? That is why germ theory was not just a new medical fact. It changed where medicine looked. Before germ theory became widely accepted, medicine often worked from visible signs. A doctor could examine a wound, feel a fever, notice the air in a sick room, or connect disease with smell, decay, and environment. These were powerful clues because they were immediate. A foul smell seemed connected to illness. Dirty surroundings seemed dangerous. Rotting matter looked unhealthy. Crowded rooms and poor conditions clearly made suffering worse. In many ways, older medicine was trying to make sense of real patterns with the tools it had. The problem was not that people saw nothing. The problem was that the most important cause, in many infectious diseases, could be outside ordinary sight. A patient could become ill even when the danger was not visible in the air. A wound could turn deadly even when the threat was not obvious on the surface. A childbirth ward could become dangerous even before anyone understood the invisible route by which infection moved. Medicine was often fighting the visible result. Germ theory slowly pointed attention toward the hidden cause. That was a difficult shift because invisible explanations are not easy to accept. Today, the word germ feels simple. Children learn that germs can spread. Adults wash their hands, cover wounds, and expect hospitals to use sterile equipment. But before microscopes, laboratory methods, and repeated evidence made microorganisms medically serious, the idea was much harder. It asked people to believe that tiny living agents, invisible to normal sight, could produce visible suffering in the human body. That is a large mental step. A fever could be felt. A wound could be seen. Bad air could be smelled. But microorganisms required a different kind of trust. They required instruments, experiments, patterns, and a new way of connecting cause and effect. Germ theory did not appear in one instant, and it was not accepted everywhere at once. Earlier ideas about contagion and invisible causes existed in different forms. But the challenge was to make the invisible medically convincing enough that practice could change. One of the most powerful early clues came not from a complete theory, but from prevention. Ignaz Semmelweis noticed something disturbing in childbirth wards. Deadly infections after childbirth were not happening randomly in the way people expected. When hand washing was introduced with a disinfecting solution, the deaths could be reduced. This mattered because it showed that a simple action could interrupt something, even before the full explanation was widely accepted. Semmelweis did not solve germ theory by himself. His work should not be treated as the whole story, but it revealed something important. Prevention could work before medicine fully understood what it was preventing. A wash basin became more than a small hospital detail. It became a clue that invisible transfer might matter. That idea was uncomfortable. If hands could carry danger from one patient to another, then disease was not only something that appeared inside the body by mystery, imbalance, or bad surroundings. It could move. It could be carried. It could be interrupted. This is where the story becomes larger than hand washing. Medicine needed a scientific bridge between invisible life and visible change. Louis Pasteur helped build that bridge. Pasteur's work made microorganisms harder to dismiss because he connected invisible living agents to visible processes. Fermentation, spoilage, decay, and debates over spontaneous generation all help show that small living organisms could produce large observable effects. A liquid could change. Food could spoil. A process could begin, not because of magic, but because something living and microscopic was active. That did not mean Pasteur alone created germ theory. The development was broader than one person, but his work helped give microorganisms scientific importance. The invisible world was no longer just a strange curiosity under a microscope. It became an active layer of reality. And once microorganisms became scientifically serious, medicine could begin asking a sharper question. Could specific microorganisms be linked to specific diseases? That question moved the story from broad possibility to stronger evidence. Robert Koch helped strengthen that link through laboratory methods. His work helped show that particular microorganisms could be connected to particular diseases in a more testable way. For general viewers, the most important idea is not the full technical detail. It is the change in evidence structure. Disease could be studied through a chain of observation, isolation, testing, and comparison. A microorganism was no longer only a possible explanation. It could become part of a method. That mattered deeply for medicine. If a specific microbe could be linked to a specific disease, then disease was no longer only a visible condition to be described after it appeared. It could be investigated at the level of cause. The microscope, the culture dish, and the laboratory notebook helped medicine trace what the eye alone could not see. This was a turning point in the way illness could be understood. But a theory changes medicine most powerfully when it changes practice. That is where Joseph Lister becomes important. Lister applied germ theory to surgery by treating infection as something that could be prevented through antiseptic practice. Surgery had always carried danger. Wounds opened the body, and infection could follow in ways that were not fully understood before the germ-based view became influential. Lister did not make surgery safe everywhere overnight. Adoption varied, methods changed, and medical practice developed gradually. But his work showed what happened when the invisible cause idea entered the surgical room. The problem was not only the visible wound. The problem could also be the invisible contamination that entered the wound. That changed the meaning of cleanliness. Clean tools were not only visually neat. Antiseptic practice was not only a ritual of order. It was a way of acting against an unseen risk. This is one of the most important legacies of germ theory. It turned prevention into something more scientifically directed. Before this shift, prevention could still exist. People had long understood that cleanliness, separation, air, environment, and habits could matter. Germ theory did not create prevention from nothing, but it helped give prevention a clearer target. The target was not only bad smell, visible dirt, or obvious decay. It was the interruption of microorganisms before they entered the body, spread between people, contaminated wounds, multiplied in the wrong place, or moved through medical practice. This changed ordinary routines. Hand hygiene became more than a personal habit. Wound cleaning became more than surface care. Sterilization became more than tidiness. Infection control became a way of managing invisible routes of spread. That is why the impact of germ theory reaches far beyond the laboratory. It sits inside the routines of hospitals. It shapes how surgical tools are prepared. It influences how wounds are cleaned. It supports the logic behind disinfecting surfaces, washing hands, and separating clean from contaminated spaces. Modern medicine is not perfect, and germ theory does not explain every disease. Not all microorganisms are harmful, and infection control depends on many details: the setting, the organism, the route of spread, the patient, the tools, the training, and the system around care. But the larger shift remains clear. Medicine learned to look beyond the visible illness and toward the invisible cause. That changed the question. Instead of only asking, "What does the sickness look like now?" medicine could increasingly ask, "What caused it? How did it move? And where can it be interrupted?" This is why a simple act like hand washing carries more history than it seems. When water runs over someone's hands today, the action looks ordinary. When a nurse cleans a wound, when surgical instruments are sterilized, when a hospital room is prepared with care, the routine may feel automatic. But behind these actions is a major change in human understanding. Germ theory taught medicine that many infectious diseases were not only mysterious suffering to be observed after the fact. They could be linked to microorganisms, traced through evidence, and interrupted through prevention. The invisible became medically real. And once medicine learned to see that hidden layer, ordinary hygiene became one of the most visible signs of a theory that changed the world.